Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of inequalities, specifically how we can graph them, and we'll do it in 5 minutes or less. So we have a blank coordinate grid here. We have an inequality. Y is less than or equal to 4x minus 6. How do we graph this? Well, we don't have any points here, but we could easily, if we think of this in our slope-intercept form, so let's just for a moment pretend that's an equal sign rather than an inequality. Right? If we have our y equals 4x minus 6, that's already in our slope-intercept form, which means, remember that plus b right there? That's going to be your y-intercept. All right, so now I already have my y-intercept. I already have a coordinate pair. It's negative 6. So the actual point right here is going to be x of 0, y of negative 6. All right, so once I've got that, I just need another point. I can create a graph. And you know what? Let's go back to what we know our m is in this slope-intercept form. That's our slope. So remember, our slope is the rise over run. So really, it's the change in y over the change in x. Okay, so 4, well, let's make that a fraction here, 4 over 1. Okay, so it's a positive, so that means it goes up 4, 1, 2, 3, 4, and over 1. So you see how I went up 4 and then over 1 plus 4 plus 1. There's my second point. Do that same thing again, 1, 2, 3, 4, and then over 1. And the same thing, 1, 2, 3, 4, over 1. And then at that point, I'm off the graph. But you know what? That gets me 4 points. Now I can draw a pretty good line here. Now we need to come back into our inequality here. So if you ever get a less than or equal to or a greater than or equal to, you're going to have a solid line. That means that any point that lies on that line is going to be included in our solution set. If you ever have just a less than or an equal to, it's going to be a dashed line. That means you cannot include any point that lies on that line. So we have a solid line here. So let's just go ahead and connect these here. The only other thing that I need to worry about, let's pretend that's straight here. There we go. Is which side are we going to shade in? Since this is an inequality, it's a whole solution set. It's not exactly just a line. So if it's ever less than or equal to, you're actually going to go below the line. If it's greater than or equal to, you're actually going to go above the line. Now this almost looks like a vertical line, but it's not quite a vertical line. It's less than, which means we're going to shade in this portion right here. So if we take any of these points right here, so let's take this point right here. Let's take that 4, 0. Let's plug that in just to make sure, right? So let's make sure we've got 0 is less than or equal to 4x. And that 4x is really 4 times 4 minus 6. So 0 is less than or equal to 16 minus 6. 0 is less than or equal to 10. All right, that checks out. All these points shaded here also check out as well. Let's look at another example. So 2x minus y is less than or equal to 6. This is in standard form, and so we don't want that. What we want is we want it to look like our slope-intercept form. So let's take 2x from both sides. That's going to leave us with minus y is less than or equal to negative 2x plus 6. We need to divide both sides by negative 1. Right, that's going to make that a positive y because that's what we're looking for. But unfortunately, that's going to flip our inequality whenever we multiply or divide by a negative. So now it's going to be y is greater than or equal to. And then we're just going to distribute that out. That's going to end up being 2x minus 6. Well, now I've got my y-intercept right here. I know my slope is up 2 over 1. So I can plot a few points here. And we know it is greater than or equal to, so that's going to be that solid line. And remember, greater than is going to be above, so that is our solution set right there.